Good morning, students. Chapter 8, Gravitation. Yes, we will see some questions today. Next question, see. Here it is. You are given two spheres. It is one sphere. It is first sphere of mass m and radius r. Okay, yes, it is first sphere of mass m and radius r. Another sphere here, another sphere is of mass 4m and radius r. Okay, so you are given two spheres of mass m and 4m and radius equal. Okay, yes, you are given two spheres and equal radius but different masses m and 4m. Okay, distance between that center, distance between that center is 6r. 6r. Okay, so yes, it is one situation given. Okay, you are given two spheres having distance 6r between that center. Now what is question? Yes, question is, okay, one object is thrown from the surface of, one object is projected from surface of this sphere having mass m directly towards another sphere, then what should be the minimum speed of this projectile so that it reaches the surface of another sphere? Do you understand question? Hello? Yes, it is one example from your textbook. Okay, so yes, that full data you can read from your textbook. Okay, I will again explain this question. Two spheres, masses m and 4m, radius equal, distance between them 6r. You have to find minimum speed of this projectile so that it reaches surface of another sphere. Okay. Now, how to solve this question? You have to find minimum speed. Minimum speed means what? Okay, see, if we want to throw some object at large distance, then obviously we have to increase its speed. Okay, if your initial speed is small, then distance travel or range it is also small. But if you throw object with maximum speed, then yes, it will travel maximum speed. But here you have to find minimum speed. So how to find this minimum speed? What is meaning of this? See, as you are given two spheres having masses, due to every mass, according to Newton's law of gravitation, okay, every object attracts another object. So if I have this body, of mass m, then it is attracted by both spheres. Yes, it is attracted by both spheres. It is attracted by both spheres. Due to this sphere, there is some field. Due to this sphere, there is some field. Okay. If object is within field of this sphere, it is attracted by this. If object is within field of this sphere, it is attracted by this. Okay, and if one mass is within object of some field, okay, then it is attracted by it. So how to solve this? See, first of all, I will find a neutral point. What is a neutral point? Neutral point. Neutral point means what? Where resultant force on object is where resultant force on object is 0. So see, on this object, if it is thrown, so it is moving. Let at this point, that is indicated by N. Okay, from this sphere at a distance r. Let at this point resultant force on object becomes 0. Means at this point gravitational force due to this sphere is equal to gravitational force due to this sphere. So at this point, resultant force on it will become 0. Resultant force on it will become 0. Okay. So yes, neutral point where resultant force on object is 0. So here I have to write, okay, let at point N, at distance r from sphere of mass and resultant force acting on object is 0. Resultant force acting on object is 0. Now see, we know that gravitational force is attractive force. So on this object, gravitational force due to this, it is in this direction. Okay, F1. And due to this sphere, it is obviously in this direction, that is F2. So yes, they are in opposite direction. If their magnitudes are same, okay, resultant force acting on object is 0. So therefore we can say F1 is equal to F2. On this object, gravitational force acting due to the sphere is equal to due to this sphere. Okay. So F1 is equal to, here it is F2. Now F1, force acting on object of mass m. Okay, due to this sphere. So yes, you know equation. What is equation? It is G m, mass of this sphere, mass of object, it is m. Distance between them, it is r square, is equal to this side. If it is distance 6r, then this distance is obviously it is 6r minus r. Okay, so for gravitational force between these two, how to write equation? It is G 4m m upon 6r minus r whole square. Okay, so G cut, m cut. So how to write? Yes, I can write this term here. So it will be, it is 6r minus r whole square divided by r square is equal to, here it is only 4. Here it is only, clear about this? Hello, clear about this? Okay, so 6r minus r whole square is equal to r square is equal to 4. So if we take square, then here it is 6r minus r upon r square. Oh, sorry, it is only r is equal to, it is plus or minus, is equal to, it is plus or minus. Clear about this? So yes, here we can take two parts. That is 6r minus r. Okay, upon r is equal to plus 2, or 6r minus r upon r is equal to minus 2. Okay, so 6r minus r is equal to, here it is 2r. If I take r this side, then it will be 6r is equal to 3r. So therefore r is equal to, it is 6r is equal to, it is 6r by 3. So therefore r is equal to, it is 2r. And this side what happens? Yes, this side it is 6r minus r is equal to minus 2r. So therefore 6r is equal to, if I take minus r, on opposite side it will become plus, so it is only minus r, and therefore r is equal to, it is minus 6r, which is not possible, which is not possible, because this object is thrown towards that sphere. So that's why we have to take this distance. Here distance r is equal to 2r, so this distance becomes 2r. Okay, so obviously this distance will become 4r. Clear about this? Okay, so what actually we have done? Okay, see. First of all, you have to find null point. Okay, where is null point? Null point means at that point gravitational force becomes 0. So what happens due to that? See, you are given two spheres. If you throw object with such speed, okay, object reaches to this point, then what happens? See, then what happens? At this point, as it is neutral point, gravitational field due to this and due to this, they are equal but in opposite direction. After this point, see, now if object is this side, it is attracted by this body. If object is this side, it is attracted by this body. It is simple concept. Okay, as it is neutral point, now if object is here in this region, it is attracted by this sphere. If object is in this region, it is attracted by this sphere. Okay, so what we have to do? We have to throw object such that it moves to this point. After this point, it is attracted by this sphere automatically. Due to its speed. Clear? Because at this point, neutral point, resultant force becomes 0. Now you are given two masses, m and 4m. So obviously due to 4m, it will attract towards it. Clear about this concept? Okay. Clear about this concept? Okay. So yes, first of all, you have to find neutral point, means where total force becomes 0. And it is at distance r is equal to 2r. Okay. It is concept like Mission Mangal at the end. Okay, if you want to launch some satellite, okay, or if you want to make some object that moves out of gravitational field of Earth and it reaches to field of another planet. Okay, so first of all, you have to throw object such that it escapes gravitational field of Earth, and then with that velocity, it has to enter in field of another planet. So once it enters in field of another planet, then due to its gravitational force, it will rotate. So we have to throw this object up to some distance only. Then after, it is attracted by field of this object itself. Okay, so yes, it is one question. Neutral point. Now you have to find, okay, what is this speed? Okay, with which speed from this point you have to throw object. Okay, so we will use law of conservation of energy. We will use concept law of conservation of energy. Okay, now let object of mass m is thrown with speed v from surface of sphere of mass m. Okay, let object is thrown with speed v from surface of sphere of mass m. Okay. So what happens? Here it is. Here it is. Yes. According to law of conservation of energy of object on surface of sphere of mass m is equal to energy of object at point n. We use law of conservation of energy, that is find energy on surface of sphere of mass m and energy at point n. Energy means kinetic energy plus potential energy. Kinetic energy plus potential energy. Then how to write equations? See, from surface. Now that object of mass m is thrown with speed v from surface of sphere of mass m. So here its speed is v. Here its speed is v. So it is half mv square. Now what about potential energy? Potential energy, yes, potential energy. First of all, you have to find. Okay, how many objects are there? 3. 2 spheres and 1 object which is thrown, and 1 object which is thrown. Okay, so yes, you are given 3 objects. So go simple. Okay, on this object, gravitational potential energy is due to this sphere and due to this sphere. Simple. Again, for this object, gravitational potential energy is due to this sphere plus this sphere. Okay, so first of all, due to this sphere, you know what is the equation? Minus g m1 m2 upon r. So due to this sphere, it is minus g. What is mass of this sphere? Capital M. Mass of object? It is m. And see, as this body is on surface of this sphere, what is distance between center and surface? It is r. So here it is. Simple. Okay. Now, due to this sphere. Okay. What is potential energy of this object due to this sphere? So what happens? See, it is again minus g. 4 is replaced by 4m. M divided by what is distance from this center to this point? From the center to this point. Yes, it is distance r. It is distance r. So what is this total distance? Yes, this total distance it is 5r. This total distance it is 5r because the center to center distance is 6. So here you have to write 5r. Clear? So at this point, kinetic energy half mv square, potential energy due to this sphere minus g mm upon r. Potential energy due to this sphere is minus g 4mm upon 5r. Okay. Now, energy of object at point n is at this point. As it is neutral point, here force will be 0. Here force will be 0. Okay. So yes, at this point, see what happens. If you throw object with speed v, it is moving, its speed decreases. At this point, its speed will become 0 because force acting at this point is 0. So here, kinetic energy will be 0. So it is equal to its kinetic energy 0. Okay. Now again, at this point, potential energy due to this sphere and this sphere. So at this point, potential energy due to this one. How to write? It is minus g m upon what is distance between this point and center of this sphere? It is 2r that we have obtained. Okay, that we have obtained. Now due to this sphere, that is minus g 4m upon distance between them it is 4r. Distance between them it is 4r. Okay? Any doubt? So therefore it is. Now how to simplify? So see, first of all, this m cut. Okay, here it is v square by 2. Here it is v square by 2. Okay, take these all terms in opposite direction, opposite side. So is equal to, it is minus gm upon 2r. Okay, then 4 cut. Okay, so it is minus gm upon r. Now if I take this minus gm upon r on opposite side, it will become plus gm upon r. It will also become plus 4 by 5 gm upon r. Any doubt? Okay, so see, this minus gm upon r, this gm upon r cancel. So therefore, v square by 2 is equal to, it is minus gm upon 2r, and here it is 4 gm upon r. Okay, so if I take gm upon r common, gm upon r common, it is minus 1 by 2 plus it is 4 by minus 1 by 2 plus it is 4 by 5. Okay, so is equal to, it is gm upon r. In bracket, 4 into minus 1, sorry, 5 into minus 1 means it is minus 5, plus 4 into 2 means it is 8. Divide is 2 into 5, is 2 into 5. Any doubt? So therefore, here it is v square by 2 is equal to, it is gm upon r minus 5 plus, minus 5 plus 8, so it is 3 divided by 2 into 5. So this 2 cut, this 2 cut. Okay, so what is v? V is equal to, it is under root 3 gm upon 5. It is 3 gm upon 5. So yes, it is your answer. Clear? What is concerned? You have to throw with minimum speed. So with this minimum speed, if I throw object with that speed, it will move up to this point. And after this point, it is attracted by this sphere. It is attracted by this sphere. No force is required then. No force is required. Okay. And after this point, it is attracted by the sphere only. So we have to just throw object up to this point. Okay. Throw up to this point only. Throw up to this point only. Throw up to this point only. After that, it is attracted by itself due to this sphere. Clear about this question? So yes, it is one lengthy question and one important question that you have to remember. Okay, so this is it for today.